like this. No, there is not a big shade. I think that's enough. Hey, what's up, Brave New World? It's Joshua again here with a brand new video of this section that I enjoy calling Astronomy Support. And why do I enjoy calling it Astronomy Support? Because we precisely talk about the Earth and about this space and a little bit of astronomy with the kind words of Mr. Isaac Asimov. As you can see, I am naturally not a Mr. Isaac Asimov, but I have some source that can be totally. I have some source. I have a book that was written by him. Therefore, I can totally say that I'm kind of quoting him, and you could actually say that this section, Astronomy Support, it's being constructed by him in a way. Let's call it that way. And by the way, a big shout out for Irving. Irving, my friend, if you're watching this is for you because you chose the number 32. You chose the number 32. I have already made a video about the question number 30. Therefore, I'm going to make a natural sequel to that particular one that you liked. Wait a second. Yes, I'm going to make a kind of sequel for that, a sequel to that video, and I'm going to do it right here. Let's take a look at what the number 32 holds for us, shall we? And what can be a section of astronomy support without throwing some trash to flat earthers? Again, you are a big shame to the human species, and you are one of the reasons I feel ashamed to be a human. And also, you're a big waste of air, and I can't believe I get to share breathable air with you guys. And if you want to use these ships to prove that the Earth is flat, just remember that the navigation devices used by those ships that you want to use in this amazing trip to prove that the Earth is flat are based on a design of a spherical, round Earth. Now, speaking about round Earth, now that I mentioned now that I mentioned the flat earthers and the shape of the Earth and the shape on which those objects are based, those devices of navigation and ships, this is actually a perfect mention that gives us a perfect material to make a smooth transition into the topic of today, which is question number 32. Question number 2. Is the Earth a perfect sphere? Let's find out what Mr. Asimov says about that, shall we? Alright. It goes like this. It goes like this. As we learn more and more about the Earth, it becomes possible to ask more detailed questions. For instance, scientists have known for nearly 2,500 years that the Earth is a sphere. But is it a perfect sphere? That's actually a good question, because I remember from some particular books, websites, and videos that the Earth has a gravitational center, right? And this gravitational center has two magnetic poles, the north and south, and this gravitational center is what causes all the matter to gather into one place, because it has a gravitational pull. However, it can be sometimes kind of irregular, so it's not entirely a sphere, but an almost spherical looking oval, oval, which means it has the shape of an egg. Alright, it has the shape of an egg. Not a really elongated one, but it's a rather round one, right? But why shouldn't it be? If the Earth is a sphere because the pull of gravity draws its substance as closely as possible to the center, then it should indeed be a perfect sphere. Besides, the sun makes a perfect circle in the sky at all times, and so does the moon, which means that these bodies are perfect spheres. If they are spheres, guys, flat earthers, the Earth is a sphere too. Damn it, I hate this mustache. I should have shaved before I started recording this, but anyway, it's too late. The first evidence to upset the notion that the side of Jupiter and Saturn through a telescope in the early The first evidence to upset that notion was the sight of Jupiter and Saturn through a telescope in the early 1600s. Oh my god, the 600s. Wow. Both seem to be elliptical rather than circle in appearance, and they maintained that shape as they turned. What's more, the longest diameter of the planetary ellipse in these two cases seemed to be that of the equators of those planets, which means that they were both spheres that bulged at the equator and were flattened at the poles. If by any chance there is an astronomer or an astrophysicist watching this video, please do fact check this. Please do fact check this video. What's more, the longest diameter of the planetary ellipse on those two cases seemed to be that of the equators of these planets, which means that they were both spheres that bulged at the equator and were flattened at the poles. Bodies of which this is true are called oblate spheroids. Oblate spheroids. Oblate, O-B-L-A-T-E, spheroids. S-P-H-E-R-O-I-D-S, oval spheroids. As I said, it has the shape of an egg. That's actually the origin of the word, from Latin. Why should Jupiter and Saturn have oblate? Why should Jupiter and Saturn be oblate spheroids? The answer did not come until Newton worked out its laws of motion and tackled the problem in 1687. Every particle of a planet is forced to turn as the planet rotates on its axis. Although the natural tendency is for an object, once it is moving, to continue onward in a straight line. There is a compromise then. The planet turns, but the surface bulges out slightly as it does so, as though it felt the tendency not to turn, but to move straight ahead. This is a centrifugal effect, from the Latin word meaning to fly from the center. Centrifuga, or if I want to use the classical Latin pronunciation, centrifuga, but I'm not sure if it is entirely correct. A phenomenon that has been studied in detail here on Earth. The faster an object rotates, the farther it bulges outward. So the flat earthers are not wrong, but neither are they right. Feel free to quote me on this one. The flat earthers are not wrong, but neither are they entirely right. Their notions are still rather idiotic, and it gives away a lot as to how little information their brains can process. As the planet turns, the portions of its surface near the pole make very small circles in the course of the turn. Such points don't move fast and therefore don't bulge out much. As one moves farther from the pole, the surface makes a bigger circle, but must make the turn in the same time. The points in the surface must therefore move quickly and bulge outward more, an effect which reaches its maximum at the equator. Thus, there is a central bulge on a turning planet, one that is deepest at the equator itself. The size of the equatorial bulge of a world depends on how fast the surface moves and how strongly the world's gravitational pull resists the formation of a bulge. The Moon, Venus, and Mercury all spin so slowly that there is no equatorial bulge worth mentioning in any of these cases. On the other hand, the Sun spins quite rapidly, and a point on its equator travels at the speed of 13,600 kilometers per hour, which is equivalent to 8,500 miles per hour. But its gravitational pull is so intense that there is no equatorial bulge worth mentioning either. Bulge, B-U-L-G-E, bulge. Correct me if I'm wrong, but bulge can also, it's basically a protuberance or something like that. Kind of like a big formation of of a body over there, I think. Correct me if I'm wrong, but I think a bulge can be, you can use the word bulge to refer to the to the portion, to that particular meaty portion that forms in the crotch of men, which means that's where their female genitalia are, meaning their penis and their testicles. Correct me if I'm wrong, but I think that's what a bulge is. Jupiter and Saturn are large compared with the Earth, and they rotate on their axis more rapidly. Jupiter rotates in a little less than 10 hours, and Saturn, though somewhat smaller, is a little over 10 hours. A point on Jupiter's equator travels for 45,765 kilometers per hour, which is equals to 28,400 miles per hour, while a point on Saturn's equator travels at 36,850 kilometers per hour. All of that is equal to 22,900 miles per hour. These are faster motions than those on points on the Sun's equator, and both Jupiter and Saturn have much smaller gravitational pulls than the Sun has. Not enough to resist the centrifugal effect. Therefore, both planets have pronounced equatorial bulges. Saturn's surface moves less rapidly than Jupiter's, but Saturn also has a smaller gravitational pull and thus has a greater equatorial bulge. So they are like a big, large penis or something like that. I don't think I'm comfortable with using that word, but hey, let's call the things by its name, shall we? A bulge, that's what it is. An abultation, I'm not sure if that word exists. Correct me if I'm wrong. But if all this is true of Jupiter and Saturn, might it not also be true for the Earth? The Earth spins on its axis more quickly than the Moon, Mercury, or Venus. A point on Earth's equator travels at a speed of 1,670 kilometers per hour, which is much less than the equatorial speeds of the Sun, Jupiter, and Saturn. But Earth's gravitational pull is much less too. It seemed to Newton that the Earth's equatorial bulge ought to be large enough to measure. And by the way, that measure that I previously, and that velocity, that speed that I previously mentioned, which is a point in the equator moves at 1,670 kilometers per hour, that one in miles is equals to 1,040 miles per hour. That's the conversion. So take it. One thing I could use to trash people would be the fact that they refuse to use that horrible imperial system, which the empire does not even use anymore. And by empire I mean the British Empire, of course. By which I mean, of course, the British Empire. So let us continue with the next part, which is the way to test this theory would be to go to various parts of the Earth and make careful measurements of distances and angles so that we could tell how much the surface of the Earth curved. If the Earth was a perfect sphere, it would curve equally everywhere. If it was an oblate spheroid, it would curve much more near the equator than near the poles. In 1736, a French expedition under Pierre-Louis de Maupertuis, born in 1688 and died in 1759, went to Lapland, near the North Pole, to measure the curvature there. At the same time, another French expedition under Charles de la Condamine, born in 1701 and died in 1774, went to Peru, near the equator, also to measure the Earth's curvature. Newton proved to be right. The Earth had a Newton proved to be right, meaning that the Earth had an equatorial bulge, though not much of one for real. The Earth's equatorial diameter is 12,756 kilometers, which is equals to 7,926 miles, while its polar diameter is, oh my god, really? 12,713 kilometers, which is equals to 7,900 miles. The difference is 43 kilometers, which is equals to 26 miles. In other words, the Earth is almost a perfect sphere, but not quite. This also additionally throws more dirt, rightfully and matter-of-factly, to flat earthers. Again, you are not wrong, but neither are you completely right, because the Earth is not a perfect spherical, it's not in a perfect spherical shape, but an irregular sphere. That's what the Earth is, an irregular sphere. An irregular sphere. An irregular sphere. No, I can't. Jeremy Irons, if it's possible that you watch this video, please do pronounce that word. An almost perfect, almost a perfect sphere. In 1959, a satellite called Vanguard 1 was placed in orbit around the Earth by the United States. From the precise manner in which it circled the Earth, it could be calculated that the equatorial bulge was 7.6 meters, 25 feet, higher south of the equator than north of the equator. This was announced as proof that the Earth was pear-shaped. Chavala! Miguel, how are you, man? Alright, let's continue. That was announced as proof that the Earth was pear-shaped. That is, broader in the southern half than that in the northern. It was an unfortunate remark, for the difference in the bulge is measurable only under the most delicate conditions. A regular sphere, not fear, sphere. S-P-H-E-R-E. S-P-H-E-R-E. An irregular sphere, but it's not flat like those idiots believe. Let us continue. Pretty well, my friend. Good to see you. This is officially the first time that I see you while I'm transmitting, Miguel. Feel free to make any comments as I am reading this section, that is question number 2 from my new section in my YouTube channel, Astronomy Support. Question number 32. Is the Earth a perfect sphere? Is the Earth a perfect sphere? Yes, a sphere. S-P-H-E-R-E. Let us continue. So, going back to the idea that was being read from this book, in fact, the entire bulge is so small as to be visible at all to the unaided eye. And to anyone looking at the Earth from space, it would appear to be a perfect sphere. Calling the Earth pear-shaped made some people think that, as seen from space, the Earth was shaped like a Bartlett pear. By Bartlett, I'm spelling it like B-A-R-T-L-E-T-T, which is an utterly false picture of that situation. Fortunately, the use of that expression quickly died. And just like that, hopefully I do honestly believe that the silly and unscientific and illogical belief that the Earth is flat will hopefully die too. After all, it's thing about natural selection, which Darwin was kind of right. Survival of the fittest, but I would re-paraphrase it as survival of the smartest. I'm not belching in front of the camera. And even if I did, I would apologize, that's for sure. I would like to apologize if someone heard me belching. I don't like the shape of my chin. Anyway, in other news, that's what the section was about, which was basically that the Earth is not a perfect sphere, but it is shaped like one because the center pulls the gravity towards it. All right. Basically, it's like a large ball of fire, which has a gravitational pull, and as a result, it attracts things. Alright? Thank you so much, Brave New World, for being here with us today. One more time, Irving, if you're watching, this is for you. And additionally, I would like to say farewell, and I'll see you in the next video of this section of my channel called Astronomy Support with Dr. Isaac Asimov. Alright? Thank you so much. Have a wonderful night.